All right, so this is Leetcode, kth smallest element in a binary search tree. So it says given the root of a binary search tree and the integer k, return the kth smallest value, one indexed, of all the values of the nodes in the tree. So they're basically saying if you put these values in order from least to greatest, return the first value, basically, the smallest value. Yep. So instead of this one index, we'll just do 1 minus, or k minus 1. And I have written articles. So I do have Medium article, but Medium charges. So I do have it in a code lab as well. And so this is free on my website. I'll put a link in the description. So I'll probably put it here moving forward first before Medium. And yeah, that way it stays free for everybody. And you don't have to have a Medium membership to actually look at everything. So you can copy the code easily and whatever. Yeah. And so, yeah, I'm still working on it. I kind of copy. I need to remove that, but yeah. So my two approaches, you've probably seen on the articles, in order traversal, which will give you the values in order, and we can do that iteratively and recursively. And I'll do the recursive approach first, I guess. And so with that approach, I chose to have a list, an array list of ints, and then we'll have a recursive function that we pass the list to. So in order, I'll just do in order. Just keep it simple. And we'll pass the root, which will be a nullable tree node, same as what they give us. And then so also have a list. I'll pass the list of array list of ints. And I'm not going to return anything. We could, but I'm not for this. And so I have base case if root equals null. Return. And then so it'll be just the basic in order traversal. So in order root.left, and then we'll add it to the list once we get to this point. After, yeah. So it'll be root.val, and since I don't know why they name it val, because it's a reserved Kotlin keyword, which is used to make a variable immutable. Yeah, but we'll also, of course, do it in order traversal on the right node, and then we'll call this function. So we'll just pass root list, and then we'll just return list k minus 1. And it's k minus 1 because it's one indexed, as they mentioned. So I'll just run this code. Oh, of course, I forgot to pass the lists. And yeah, so we'll go ahead and submit it. So the iterative approach is, of course, similar, just to a basic iterative in order traversal. All right, so for the iterative approach, of course, we use stack. So the traditional iterative in order traversal. So have a stack of tree nodes. And since root and k are immutable, I want to make copies of those. Index defined, I guess. I don't know. And I want to use index defined to basically decrement while we're already traversing in order. Then we could just return that value. Yeah, so we'll do, well, temp is not equal to null, and or stack is not empty. or size is bigger than 0. Either way, we'll do while temp is not equal to null. Then we'll push temp to the stack, and then we'll traverse all of the left nodes, of course. Then after that while loop is done, we know we found like a leaf node or after a leaf node, and so it's null basically. We're on a null node. So we'll set temp equals to stack.pop, which will take us back to the previous leaf node that we were on. So the parent node of the current null node. And yeah, so we want to check temp. Or it's a nullable tree node, so yeah. Anyways, this is where we can check the current, or I guess I named the index defined. And actually I want to pre-decrement it and check if it's equal to 0, and if it is, we can return it.val. We have to put the backticks because Kotlin or val is of course the keyword in Kotlin to make the variable immutable. So yeah, and then we'll set temp equals to temp.right because we want to, of course, traverse through the right node after we traverse through all of the left nodes. And then we can return -1 if the first root is null, but the constraint tell you that it will always be bigger than 0, I believe, yeah. And so I can just run it real quick, I guess. Or, oh yeah, okay. And so, yeah, I'll submit it. So this is a little bit faster than the recursive approach. But yeah, so that's how to solve Kate's smallest element in a binary search tree on Leetcode number 230, a medium question. And yep, thank you for watching.